Okay, our next type of factoring, trinomials with a equal to 1. Specifically here, we're talking about quadratics. Let me remind you, and we say a equals 1 because the generic form of a, there we go, quadratic equation is ax squared plus bx plus c. And so when we're talking about a equals 1, we're talking about the coefficient on x squared being 1. And these are a little bit easier than some other ones. So we'll say a couple of things here. Answers will be in the form, it'll be 2 sets of parentheses, and you'll have x as the first term, and really it'll be plus or minus some number, right? Plus or minus some number. Okay, so that's the form we're going to be talking about. And here is how we find these numbers. Okay, we're going to find factors of C, right? So this value here, that add to B, this number here. Okay.
Hey, Mom, I'm taking the dog for a walk.
Okay.
Oh.
Hi, Coda. Hey, say hi, Coda. Here's my puppy. Look at the camera.
Ooh,
hi,
sorry.
buddy.
Are you recording? I'll come back later.
Okay. Have fun.
All right.
Let's see. These numbers go in the parentheses. So it's important to recognize when you're dealing with a quadratic with a equals 1 because they'll go a lot faster than the other quadratics that we're going to factor here in a little bit. So we're going to do a couple of these. Number 1, x squared plus 6x plus 8. Now I'm thinking about, I need to find two numbers that multiply to be 8 but add to be 6. Multiply to be 8, but add to be 6. So if you need to, you can make a list of them. You can make a little chart. Sometimes I'll do that. Factors of 8, add to be 6. Right? We can think of all the ways we would multiply to get 8, 1 and 8, 2 and 4. And pretty quickly we're going to see that 2 and 4 is how we would add to get 6. So 2 and 4 are the numbers, so it's x plus 2, x plus 4. That should be fairly straightforward. Let's look at one more of these. Number 2, x squared minus 5x minus 14. So now I'm looking for things that multiply to be negative 14 but add to be negative 5. Now we can be kind of smart here. Factors of negative 14. We want a sum of negative 5. So we know that if we multiply two numbers and get a negative, one of the numbers has to be negative. Furthermore, if I'm adding two numbers, one's a positive and one's a negative, and the answer is negative, we know that the larger number is negative. So I could think of all the factors of 14, 1 and negative 14, 2 and negative 7, and hopefully again, pretty soon we're going to see we have found our sum of negative 5 with 2 and negative 7. So those are the numbers that go in the parentheses, plus 2, minus 7. Okay, and so again, this should be fairly straightforward and things that you've seen before and hopefully you got pretty good at. Okay, so we'll see lots of those and we'll need to be able to factor them quickly. Normally with these, maybe without the chart, but we'll see. Yeah, so there we go. Okay, the controversial one. Oh, it's not that controversial, I guess, but here it is. Trinomials with a not equal to 1. Again, we're still dealing with quadratics here, ax squared plus bx plus c. So now when the coefficient on x squared is not a 1, what can we do? There are lots of different schools of thought about this. I am going to mention a couple of them. First, some teachers like the guess and check method, right? Guess and check, just like guess some factors and see what happens. I don't love this method, only because, in my opinion, when you get into some larger coefficient polynomials that are quadratics, it could take you quite a bit of time to guess and check if you're not very strategic about it. So that's why I don't love that one. I'm assuming that if you had Mrs. Fee last year, you probably did something called X factor. And I'll be honest with you, I'm not clear about that method. So you won't see me doing the X factor method. When I return, we can talk about that. But again, if you're good at this method, if you remember how to do it, I think it's great. Go for it. If it makes sense to you, that's awesome. It's not my favorite. So the method that I'm going to use to factor these is going to be called, well, actually, it's using a method we've already talked about. It's using grouping. Okay? So that's the one that I'm going to be using, and you'll see me use that actually quite a bit. Okay? And I'm going to show you, I think, maybe with an example to begin with, how we use grouping. So we're going to have 8x squared minus 10x and minus 3. Okay. Now, in order to do grouping, if you remember on the grouping method, we said grouping was useful if we had 4 terms. Okay. We don't have 4 terms. We only have 3 terms. But we can make it 4 terms. And so what we're going to be doing is, I'm going to write this down on the side over here. Different color. Okay. I'm going to say rewrite the middle term, which in our case is negative 10x, strategically. Strategically, yes. As the sum of 2 terms. So if I break up that middle term, this negative 10x, into 2 different terms, then we'll have 4 terms. Okay? But the key word here is that we have to do it strategically. We can't just haphazardly rewrite it. Okay? So there is a way to do that. We're going to start by multiply. This is the first step, A times C. Okay. So in our problem, that's going to be 8 times negative 3 or negative 24. Okay. Then we're going to look for factors of A times C that add to B. So similar to what we were doing on the last one, where we're looking for factors of some number that add up to be another number. So in our case, here's A times C, okay, and here is B. So I might even make another little chart. So I'm going to say A times C is, that's negative 24, negative 10, that's B. So I need to think about ways that I can multiply to get negative 24, add to get negative 10. Again, we're multiplying 2 numbers to get a negative, so that's a positive times a negative. And I want to add a positive and a negative and get a negative, meaning the larger number needs to be negative. So I'm just going to start by making a list. I usually start kind of strategically again with just the lowest like 1 times negative 24, 2 times negative 12, 3 times negative 8, 4 times negative 6. But hopefully, ding, 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 you've already seen that it's on the list. Here it is, 2 and negative 12. Okay. Now, we're not using those numbers to factor this time. Okay. Now we're going to rewrite the middle term using these numbers as, hey, I'm making a video here, as coefficients. Okay, so this will be now 8x squared. That didn't change. Now I'm going to use these, the 2 and the negative 12. So I might have plus 2x minus 12x minus 3. Now can we all agree that 2x minus 12x would still be negative 10x? You can see I haven't changed this at all. Okay. Now, again, we've got 4 terms, so we can do some grouping. What do 8x squared and 2x have in common? They have a 2x in common. What's left over is 4x, plus, what happens when I divide here? 2 divided by 2, that's 1, don't forget the 1. What do negative 12x and negative 3 have in common? A negative 3. What's left over? Negative 12 divided by negative 3 is 4, we still have an x. Negative 3 divided by negative 3 is positive 1. And now, again, we can group. We're looking at these 2 terms. What do they have in common? They have 4x plus 1 in common. What's left over is 2x out of that one and a minus 3 out of that one. Okay? And that is how we factor with this method. Okay? All right, I'm about out of time on this one, so I'm going to stop it, and we'll do another example in a moment.